Hi, seventh graders. We are going to talk about similar triangles today and similar figures. And so, what similar triangles are when two angles in one triangle are congruent to two angles in another triangle. Then that automatically means that that third angle is going to be congruent. And so we call those similar triangles. And so basically, as long as the angles are congruent, the size might be different, okay? But if the angles are all congruent, then we say that they are similar triangles. So here's the little symbol that we use to represent that. And so in this example, we have our first triangle has angles that measure 65 degrees, 95 degrees, and 20 degrees. And the second triangle has those same angle measurements. Notice that the second triangle is a little bit bigger, but because the angles are congruent, that makes these two triangles similar. So here it says determine if the triangles are similar or not. On the first triangle, we're given two of the angles, and we're also given two of the angles on the second triangle. And so what we would want to do is figure out those third angles and confirm whether or not they're congruent angles. So remember that the sum of the angles in a triangle is going to be 180 degrees. So I know that 28 plus 80 plus x needs to equal 180. And then when I go ahead and finish solving this to figure out what x is, we're going to figure out that x has to equal 72 degrees. So when I look at these two triangles, I see that they both have a 28-degree angle, all right? On the second triangle, I could go ahead and solve for y, but I actually have enough information right now to determine whether or not they're similar or not. So they do have one congruent angle, but we have a 72-degree angle here and 80 degrees, and then neither one of those matches up with that 71 degrees. So because there's not at least two angles congruent, these would be not similar triangles. So if I look at this example over here, again, I'm given two angles in the top triangle, two angles in the bottom triangle, and so I want to solve for the third angle in one of them so that I have something to compare to and see if they have at least two congruent angles, which would make the triangles similar. So I can tell right now that they both have that 90-degree angle, and so now I need to see if any other angles are going to match up. So I can go ahead and solve. So we know that 90 plus 66 plus x has to equal 180. And so then if I finish solving this, I'm going to figure out that x needs to be 24 degrees. All right. So when I look here, this triangle also has a 24-degree angle. All right. So because they have two angles that are identical and congruent, by default, that tells us that the third angle has to be congruent as well. So I could go ahead and solve for y right now, but because the two angles match up, that tells me that that third angle by default has to be congruent as well. So these two triangles have all congruent angles, and so even though they're different sizes, because their angles are congruent, we can call them similar triangles. So where similar figures help us is similar figures are proportional to each other and have corresponding sides that are proportional. So when I'm given the information that shapes are similar, I can use a proportion to figure out a missing side length. So for example, here I know that these two triangles are similar. And so I'm trying to solve and figure out what that measurement of A is. And so what I can do is I can write a proportion. So I know that I'm going to need to solve for A, so I'm going to have A there. And then I'm going to choose one of the other sides on this triangle that I know. So I know that one side is 4 meters. And so for the other side of my proportion, I just want to make sure that I match up what we call corresponding sides. So if you think of corresponding angles on our parallel lines and transversals, the corresponding angles are the angles that kind of match up in the same location, okay? And so it's the same idea here. So for example, the side that corresponds with the A on this triangle is going to end up being the 6 on this triangle. So if we were to rotate this smaller triangle around and kind of match them up, the A and the 6 would line up. So I know that those two correspond, so they need to be in the same location in the proportion. And then my other corresponding sides, if I'm using this measurement of the 4, that corresponds to this measurement of the 10. So when I have a proportion set up, then I just need to solve my proportion. So there's a variety of strategies you can use to solve proportions. You can look for a relationship between two numbers. You can use cross products to solve. So for example, on this one, the cross product method will always work. So I can know that 6 times 4 has to equal 10 times A. 6 times 4 is 24. And so then to solve for A, I can divide by 10 to figure out that this is going to be 2.4. So then I've solved for my missing side length on that triangle. So same idea over here with these rectangles. When I start setting up my proportion, I'm going to start with where my variable is. So I have the y over 25, and there are different ways to set up a proportion. Your main, the main thing you want to pay attention to is that you have a relationship between the two numbers that you're putting together. So like the y and the 25 are both on the same rectangle, so that's why I can put them together. It doesn't really matter if I put the 25 on top or the y on the bottom. And so when I come over to the other rectangle, I want to make sure that I'm using corresponding sides. So if I look at which side corresponds to the length of y, that's going to be my 7 over here. So I want to make sure that I write 7 lined up with the y. And then I'm going to look for my other corresponding side to 25, which is going to be this 10. And then again, from here, it's just a matter of solving a proportion. So you might notice a relationship. I know that 10 times 2.5 is going to give me 25, so I could do that same relationship up here and multiply times 2.5, which would then allow me to figure out that missing side length, or I can use my cross products as well. And so when we do that, we're going to get 17.5 meters as the width over here. So where this comes into play, we can also use similar triangles and similar figures to help find missing measurements. So for example, if we have a picture like the one shown here that says you plan to cross a river and want to know how far it is to travel to the other side, so that's right here. So you take measurements on your side of the river and make the drawing shown. And part A says explain why triangle ABC and triangle DEC are similar. So first we want to be able to prove that these two triangles are similar, because our proportions will only work if these are similar triangles. So for them to be similar, they need at least two angles to be congruent. Right now, it's pretty easy to see that they both have a right angle, all right? But that doesn't necessarily mean that their other angles are going to be congruent either. So if we look at this on this particular diagram, where these two triangles are kind of meeting, remember, these are what we call vertical angles. So when we think back to all of our different angle relationships we've talked about this entire semester, these two angles are vertical. Vertical angles are congruent. So that means that this angle is congruent to this angle. And so when they're congruent, now I have at least two angles congruent, which means that these are similar triangles. So that means I can use a proportion to solve for my missing this x here. Okay, so when we set up our proportion, we just want to make sure that we're matching up our corresponding sides. So that x and the 40 are both on that lower triangle, so I'm going to put them together. And then now what I need to do is I need to imagine that this triangle is rotated, and I need to think of which side of that, which side would correspond with the x, okay? And so if I were to rotate that, all right, it's actually going to be this 50 feet that corresponds with the x. And then the, oops, I'm sorry, ignore that. So if I were to rotate this, the 60 feet corresponds with the x. So that means I want the 60 up here, and then the 50 corresponds to this 40 foot measurement. So again, if we imagine that those triangles are rotated the same way, that's how we get our proportion set up. And so then from here, it's just a matter of solving your proportion. You can use cross products. You can look for other relationships that you notice. Either way, when you solve this, you should get that x is going to equal 48, which tells us then that our distance is 48 feet across the river. All right, have a wonderful day.